Diffraction of the wave. Now some questions related to the properties. First question on diffraction. First thing in this picture, example, if this one is A and B, which one is a longer wavelength, which one is shorter wavelength? In which picture is a shorter wavelength? So A is a short wavelength and B is a long wavelength or longer wavelength. When it passes through this edge, which one will, when passes through the gap, which one diffract more? The longer one will diffract more, so as it passes through the gap, it's spread out and signal will be received. But for a shorter wavelength, it will diffract, but small amount of diffraction. So antenna is not able to catch this wave. Which one is representing a diffraction? Which picture? Which is representing a diffraction? Like example, which of these shows how the rays reflected? First one is reflected. Which one is showing reflection? So C is showing reflection. Which of them diffracted at a gap? Diffracted at a gap or through the gap. Which of them is representing diffraction through the gap? So diffraction through the gap is A. Which is showing a refracted ray? Which one is showing a refracted ray? Refracted means the wave which changes the speed only. So C is representing a refracted, and which is diffracted at the edge. So at the edge you can see part of the wave only diffracted, one part is. Which of these shows a wave reflected? What's the answer for reflected one? Which one is showing the wave reflected? So B is the right answer for reflected. Which of them is showing a diffraction at a gap?
D.
D is representing a diffraction at a gap. Which of them is showing a refraction, a change in speed? A. And which of them is representing a diffraction through the edge when it passing near the edge? So C is representing diffraction at an edge. Okay. More questions related to this topic? Different waves hit the barrier with different size. So different wave hits barrier with different size gap. The wave will diffract, and which diagram shows the greatest spreading occur or greater diffraction occur? Diffraction is maximum when the wavelength is equal to the gap size. Which is the right answer?
D.
wavelength is equal to gap size, maximum diffraction occur.
Oh, yes, baby.
So B is the right answer. When the gap size and wavelength are equal, maximum diffraction occur.
And when the gap size is smaller than the wavelength?
When the gap size is smaller, then diffraction will occur, but the intensity or amount of diffraction or amount of energy decreases. Diffraction will be there, but small as compared to maximum when they are equal. Okay. If I complete the pattern here, the wavelength is smaller than the gap, so diffraction, very small amount of diffraction. This kind of pattern will be there. Here the wavelength, again the gap size is much bigger, very small amount of diffraction. Here the wavelength is smaller and the gap size is again bigger than small diffraction. But when the gap size is also smaller than the wavelength, diffraction will occur, but compared to the equal one, it is less. The gap size is smaller and the wavelength is larger. Spreading will occur, but compare to when wavelength is approximately equal to gap, that is maximum. Question 4. The diagram represents a plane wavefront being diffracted by passing through a gap in a barrier. Which pair of change must increase amount of diffraction? Means what I should do to increase the diffraction. In the picture, you can see the wavelength is smaller and the gap is bigger. So what I should do so that I will have a maximum diffraction? What change we should do to this so that maximum diffraction occurs? So what we should do, we want to make them same size. So how I can make same size? Because the wavelength is smaller, so I should increase the wavelength. And the gap size is bigger, so I should decrease the gap size. So increase the wavelength and decrease the gap size until they will be same. So that's why maximum diffraction will occur. The diagram represents a plane wavefront of a water wave about to strike a solid. Which diagram shows the position of a water, represent the position of a wavefront after the reflection at the barrier?
C.
C is the right answer. How C is the right answer? Look, the easy thing to understand the reflection, it's better you draw. Roughly you can sketch. So this is
90
the this is the direction in which the wave is striking the surface. Then imaginary line which is perpendicular to the surface, that imaginary line is known as the normal. An angle of incidence and angle of reflection should be same. So as the wave bounces back, and then draw the wave fronts, which are 90 degrees. Is it clear? Plane wavefront travel from a shallow region to deep region. They travel more quickly in a deep water. Which diagram shows how the wave pattern in a deep water will appear?
B. B.
In a deep region, they move faster. In a shallow, they are moving slower. In a deep, they are moving faster.
Yeah, B.
So what happened? Because it will move faster. So in a deep region, they will be ahead. And first thing, in a shallow region, the wavelength should be smaller. In a deep region, the wavelength should be greater. So which one? There's an increase in the wavelength. So either A can be answered or C can be answered. B and D cannot be an answer because the wavelength decreases. But in a deep region, the wavelength should be higher. Then second thing, what you identify, because in a deep region, it will travel faster. So if there is a wave front, the part of the wave is in a shallow region and small part is in a deep region. So in a deep region, it will travel faster. So it will be ahead as compared to that in a shallow region. So C is the correct answer. Is it okay? Clear now?
Yes, sir.
What's the answer for, look, Yusuf, in this question, they ask you have to identify a pattern of the wave in a deeper region. In a deeper region, the wave travel faster. Look, these are the wave front, okay? If the wave front, if wave is moving faster, then the wave front will be ahead in a deep region. If it is traveling slower, the wave front will lag behind in a region. Because they mentioned they're traveling more quickly in a deep region, so the part of the wave which is in a deep region should move faster. So that's why the part of the wavefront which are in a deep region are ahead of part of the wavefront which is in a shallow region. So which pattern it appeared? That it appeared to be C. Question 8. What is the answer? The diagram shows a water wave approaches a barrier with a gap. The wave reaches point P. What is the name of the effect as the water reaches point P? So wave, as it passes through a gap, it's spread out, and spreading of a wave is known as diffraction. The diagram shows a plane wave reflected by a plane surface. Which line represent a wavefront? Which line represent a wavefront? A is the direction of the wave, because direction of the wave is always perpendicular to direction of the wavefront. A is the direction of the wave. B, the distance between the two successive crests. B is actually a wavelength. D is a reflecting surface. And C is actually representing the wave front. So what happened here, that the wave strike the surface, and it hits the surface, it changes the direction and bounce back. So C was the right answer for this. The diagram represents the water waves in a tank. Which diagram represent the water, which diagram represent a wave that changes speed? Which one is representing the wave changes speed? A, B, C, or D? Yeah, it is D, because as the wave travels from deep to shallow, in a deep region, the wave is moving faster. In a shallow region, the wave is moving slower. Question 20. The diagram shows a water wave passing through a gap in a harbor. The wave curves round the wall and reaches a small boat. So means diffraction occur. What is the name of this curving effect and how the gap can be changed so that water less likely to reach? We want to reduce the diffraction. So what we should do? We want to reduce the diffraction.
Make the gap bigger.
Make the gap bigger. So because if you want to reduce the diffraction, we should make the gap bigger. A is the right answer for this. Okay, in this question, figure 6.2 shows a water waves crossing a boundary from a shallow to deep. So shallow region to deep region, the water wave crosses the boundary. Name the process that take place at the boundary between a shallow and deep region. What happened? When move from one medium to another and change the speed, what we call? This phenomena is known as refraction, not diffraction. Property of a wave to travel from one medium to another by changing the speed. So refraction occur. The next part, take one box correspond to the property of a wave that is same in the shallow as in the deep region. Which property is same in both in deep and shallow region? Yeah, that's right. The frequency does not change, so it remains same. Amplitude or the size, height of the wave, speed of the wave, and the wavelength, all these. Moving from deep to shallow, it increases, and moving from shallow to deep, it will. So moving from deep to shallow, it decreases, and moving from shallow to deep, it will increase. But the frequency remain unchanged. What is meant by the term frequency? Frequency means number of vibrations or number of waves in 1 second. We call frequency. The sound waves travel in air towards a barrier with a small gap. As shown in the figure, state what is meant by compression. How we define a compression? What is the definition of compression? The definition of a compression. So region, you have to learn the standard definition for compression here. For sound waves specifically, region or the region where the particles are closer and pressure is high. So region where the particles are closer and the pressure is high, that region is known as compression region. The width of the gap is smaller than the wavelength. Draw the pattern. So how we draw the pattern? If you can see the wavelength is bigger and the gap size is smaller, the barrier is smaller. So roughly you will sketch a maximum diffraction, but keep in mind, like if wavelength was 2 centimeter, make a second wavefront after 2 centimeter.
Sir, now like the gap between the barriers is small and the wavelength is big.
Yes.
So what?
Diffraction will occur maximum when they're approximately equal, but still you will show a greater diffraction. When the wavelength is bigger than the gap size, there is a diffraction. It is greater diffraction as compared to when the barrier is or the gap size is bigger than the wavelength. So whenever diffraction is more, how you represent? You represent by curve, which shows that the wave is spread out. But it will be maximum when the wavelength and gap are equal. The wavelength is 2 centimeter and in this example, it's like the wavelength is equals to say 3 centimeter and gap is 2 centimeter. So you will show a curve which shows that there's a diffraction or greater diffraction. Maximum when they are exactly equal. The barrier is adjusted so that the gap become wider. So you adjust the barrier so that the gap will now become wider. So what happened to diffraction if this gap is bigger or wider? It will diffract more or less?
Less.
So small amount of diffraction will occur. And how we represent a small diffraction by wavefront, we represent in this manner. But you don't have to draw for the second part. You just have to mention, describe how it affects the pattern of compression after a sound wave passes. So you will mention the diffraction. This part is actually related to sound topic. We'll discuss this part in sound, because the other parts are totally related to topic sound. Okay, in this question figure, the wave in B approaches a barrier of a large gap. You can see a large gap is there. On the figure, the gap in the barrier is larger than the wavelength. On the figure, draw a pattern. So what pattern of a crest or the wavefront you will draw? You will show a less diffraction. This shows less diffraction. If the gap was smaller, then I will show maximum diffraction curve like this. The water is added to a tank and the speed of the wave in the deep region is greater than in a shallow region. The frequency of the wave remains constant, but its wavelength is different. State and explain how the wavelength in a deeper region has changed. So what will happen to wavelength in a deeper region? So what will happen to the wavelength as it moves in a deeper region? The wavelength will increase. Speed will also increase, but the ratio remains same. So frequency unchanged. Apart from a change in wavelength, describe one other difference in the pattern formed by the crest after a wave passes through a gap. So water is added to the tank, and the speed of the wave. So what happened as the water is passing the speed of a wave in a deeper, water is greater than in a shallow. The frequency remain unchanged. Apart from a change in the wavelength, describe one other difference in the pattern form after a wave passes through the gap. So when the wave passes through the gap, frequency will not change. So what happened, you can see here in the beginning, the wavelength was smaller. In the beginning of the question, the wavelength is smaller. But when you passes through in a deep region, the wavelength increases. As the wavelength increase, now if the wavelength is equal to the gap size, so what we will observe? We will observe the wave will spread out more. Is it clear? because this is a related question. In the first question, the wavelength was smaller, so small diffraction occur. But as it passes through, like if it is in a deep region, the wavelength will be greater, or wavelength is approximately equal to the gap size. So what we'll observe? We'll observe curved wavefronts or maximum diffraction. So this was about the properties of the wave. There are more things related to, like more examples are there, but remaining example I want you to attempt, and I will share the exercise with you related to the topic. In the last part here, they mention, you can see here in the question, the wavelength is smaller than the barrier size or the gap size. So there was less diffraction. But now you pass this wave through through a deep region. So when you pass this through a deep region, what you will observe? You'll observe that the wavelength will increase. So as the wavelength increase, now the gap remains same, but the wavelength is bigger, or wavelength is equal to the gap size. So what you will observe? You will observe maximum diffraction. Okay, so I'll end the session and share the recording with you.